So let's how many we have? Let's see. We don't have more. We already finished that. We have 3 more, and that's then we're gonna do 2 or 3 more advanced example, and that's it. That's it. Then we cover the whole Newtonian mechanics. So the next example we're gonna make using the formula. Work is FD, right? So work is FD, force, okay? Work is a force times distance. Force is a vector quantity, okay? So let's make the first formula. The first one is very easy. We're gonna do 2 examples. One is just simple, and one is using the dot product. So let's see. If 10 Newton exert to move a 10 kg box to. Okay, so the question we can make using this formula is, if 10 Newton exert to move a 10 kg box to move 10 meter, find work done. Okay, so work is just simply force times distance. So force is 10 Newton and distance is 10 meter. Alright, so work done is 100 Newton meter. What does that mean? Let's see. 10 Newton is kg meter per second square, and then again you have meter. So 10 kg meter square and second square, and we know that 100, we know that is joule. So 100 joule. Alright. So now we're gonna do the next one. Last one I did.
Right.
Yeah.
Let's start over with that.
Yeah. So let's. This tape is from starting, right? From this tape. This is a new tape, right?
The last 4 minutes.
Last 4 minutes.
So
right?
whenever you're ready to start, just go ahead.
Okay. All right. Because I don't want to repeat that. So this tape.
We'll start new.
Start new. Nothing is in the tape, right? Okay.
You're starting from the top. All right. So now we're moving on to this formula.
Okay. So the last time we tried to understood the potential energy and kinetic energy, and this time we're gonna do the work. So work is force times distance. And so let's do some example using this formula, just like before. We're going to do a few examples. Let's make the first one as simple as possible. Let's see a car. Let's say 10 Newton force exert to move a cart from a cart of distance of total distance 10 meters. Find work. Calculate the work. Calculate work done. All right. So okay. So work is force times distance. The force is, the force is 10 Newton, So it's 10 Newton, and distance is well 10 meters. Okay, so 100 Newton meter and 100 Newton meter is simply joule. Okay, so let's do a more complicated question. Let's see what question we can make. Maybe well, let's see. The force you know, Fp equal maybe 40 Newton, exert to move a cart at, I guess, you know, 30 degree, 200 meter, right? So what do we need to find? Calculate the work. Calculate work. Okay, so let's draw that. Let's draw what's going on. So, you know, let's draw it here. Say a cart. This is a cart. Someone is pulling a cart. Someone is pulling a cart. Suppose someone is pulling a cart and the degree is what? 30 degree. 30 degree to east, northeast. Okay? And the force is exerting is 40 Newton. We try to find the work, right? So we can say that Fp is Fpx plus Fpy, right? Fpx plus okay, so then we can write the distance is 100 meters. So the Fpx is force is 40 Newton times cosine 30 degree, and y is 40 Newton times sine 30 degree. So 40 Newton, 40 times cosine 30 is 40 times cosine 30 degree is 34 Newton, and 40 times sine 30 is actually 20 Newton. So now this is now we can use the dot product. This is, we can say, f of xi times the meter. This is toward I is this is I, this is j, right? So this is meter I plus f of y and meter j and f of ji. Let's say this one is 34 Newton times, well, 100 meters. And this one is 20 Newton times 0. This one is 0 times 0. So 3400 Newton meter, which is 3.4 times 10 to the power 3 joule. Alright, so I hope we understand that. So let's do the next one. Next one is total energy. Total energy is kinetic energy plus potential energy plus internal energy. Kinetic energy plus potential energy plus internal energy. So remember that change of total energy is actually 0, right? So now, for example, a box, 10 kg box, falling from stairs, losing what? Potential energy. When something falling, it's losing potential energy. 10 Newton, 10 joule potential energy, and gaining 5 joule kinetic energy. Where are the other energy goes? Converted to some kind of other energy, mechanical energy, heat energy. It's converted to something else. Not that much. Say 8 joule. Find internal energy. Okay. So internal energy is total energy is 0 equal to kinetic energy plus potential energy plus internal energy. Alright? So now internal energy is so let's put 0 this side and let's see, Q is actually potential energy minus kinetic energy, which one is 10 joule minus 8 joule, and the internal change is 2 joule. Alright. So let's do the last one, and then we're gonna do some advanced example, and then we wrap up the classical mechanics. So this is the last beautiful mathematical laws of physics. I mean mechanical physics, and it says P for this time power is work over time, which we can say work is Fd over t, and d over t you can say velocity. Now let's make a question. This is, by the way, again a power. We saw it before, but we saw this one before, but we call it what? Momentum. Momentum was b. Okay, so that was momentum. This P is momentum and this P is power. So let's make an example using this formula. Let's say let's say 50 Newton exerts to move a car, to move an object distance of 10 meters for 10 seconds. Okay, calculate power. Okay, let's see. So power is Fd over T. So F is 50 Newton and D is, I guess, distance 10 meters and T is 10 seconds. Okay, so 500 Newton meter over 10 seconds. So it's going to be 50 Newton meter over second. What is Newton meter? 50 joule. Newton meter to joule per second. What is joule per second? Is 50 watt. So we use watt, the unit watt, for the power.